In this video, we'll look at how column names are assigned. We'll review some of the rules for names and some suggestions for creating good names. After that, we'll look at some of the data types that can be used with columns. Column names and the data types assigned to columns are two of the biggest factors you'll deal with when working with SQL. The rules for column names are the same as the rules for table names. We learned about those rules in the previous video. MySQL lets you use up to 64 characters in a column name. As with the table name, the characters that are allowed in a name depend upon if the name is quoted or not. The most important things to keep in mind when you assign a column name is that the name should indicate how the data in the column is used. For example, if you want to define columns to contain telephone numbers, you can use column names like phone 1, phone 2, phone 3. But better names might be home phone, work phone, and cell phone. That way you can tell just from the column name what the data in the column is used for. You can see the rules for creating column names at the URL shown on this slide. In many web development and programming jobs, you'll be working with tables that already exist. That means that you won't be defining tables and column names, but instead you'll be using existing names. Sometimes, though, you might have to create a new table and assign column names for the data in the table. If you take advantage of all of the permitted MySQL column name rules, you might end up assigning a valid column name, but one that is hard to use. On this slide, you're looking at an SQL create table statement. The reason for looking at this is not to learn about the create table statement, but to look at how MySQL deals with table and column names. The thing to notice about this slide is that all of the names, which are shown in brown, are delimited or surrounded with tick marks. The tick mark is the MySQL identifier quote character. It is located on your keyboard, probably to the left of the 1 key on the top row of the keyboard. The tick mark is used to indicate to MySQL where a name begins and ends. Now in this case, MySQL doesn't actually need the tick marks around any of the names. That is because all of the names shown here are simple names. All of the names start with an uppercase or lowercase letter. None of the names use special characters, just letters, numbers, and the underscore character. None of the names have an embedded space character. So if all of the names shown on this slide are simple names, why did the program marks around all of the names? It turns out it does not know if the name is a simple name, which does not need tick marks, or if it is more complex and needs tick marks. Rather than try to figure out if the name is simple or complex, simply puts tick marks around everything. That is always a valid option. When you start writing your own SQL statements, you can include the tick marks if you want to. But if you are using simple names, you don't need to add the tick marks. Tick marks are not standard in SQL. For example, Microsoft SQL Server uses square brace characters as identifier characters. What if you have to work with an existing table that contains complex column names? A good rule to follow is this. Always use simple but descriptive names. A simple name is a name that MySQL can work with that does not require tick mark identifiers. If you do need to create a complex name, you should have a very good reason for doing so. The two most important features of a column are its name and its data type. On this slide, you see the most commonly used data types. MySQL supports over 24 data types, but we will only look at the data types that are most widely used. The most fundamental data type is character data. Basically, a character is anything that you can type on your keyboard. One thing to realize is that any of the other data types shown on this slide can be stored as character data. For example, you can enter numbers and store them as characters, or you can type a date and store it as character data. In fact, languages like XML and JSON work only with character data, and those languages manage to contain all types of data. So if data can be stored as characters, why are there other data types? It turns out that if you specify one of the numeric or date-time data types, the data can be stored in the database using less storage. For example, look at the date data type and its description. You can see that a date data type is used to contain a value for year, month, and day. When entered or displayed, the value contains 10 characters. 4 characters for the year, a hyphen separator, 2 characters for the month, another hyphen, and 2 characters for the day. So if you decided to store a date in a character field, you would need 10 characters. The unit of measure that is used to describe how much storage is required is called a byte. So we would say that storing a date data type in a character column would require 10 bytes. It turns out that if you define a column as a date data type, the same value only requires 3 bytes of storage, less than half of the room needed for a character data type. But the amount of storage required for a particular data element is only part of the reason why you define a column using a specific data type. The far more important consideration when defining a data type is how will the data in the column be used. For example, in some applications you may need to calculate the number of days between 2 dates. For example, to calculate a future date or past due date. If you store dates as character data types, you would need to develop your own calculation routines to perform date calculations. If instead you define dates as date data type, you can use the date functions provided with SQL to perform date calculations. The same applies to numeric data. It is a very common requirement to perform calculations on numeric data. For example, if your database contains a quantity ordered and a price per unit, it would be simple to calculate the amount due by multiplying the 2 values. If the values were not numeric data, you would need to perform some character to numeric conversions first, then perform the calculation. So the most important thing to think about when defining a column is how will the data in the column be used. It is very important to think this through before you put a new table into production. If you need to convert to a different data type after you've already had data in the table, you'll need to modify the table and reload the data. Most likely, any applications that are using the table will also need to be changed. There are a lot of rules about the maximum lengths of data based on the data type, the ranges of numeric values, and other factors. Rather than go over all of the ranges now, I'll point out that you'll see many examples throughout this course of how the data types are used. The MySQL reference manual includes a complex chart that shows all of the maximum lengths and ranges.